Welcome to the first in a long series of videos that I'm going to be calling 5-Minute Math, where I try to encapsulate a singular concept from calculus in about 5 minutes. Today what we're looking at is slope versus average rate of change, and it may surprise you that we're talking about slope in a calculus class. That's an Algebra 1 topic after all. What's it doing here, and why is it our starting point? Well, it actually turns out slope is a huge part of the first half of most calculus courses. Slope really dictates what we're doing here, and we try and explore what we can start saying with it, what we can say about it, and what it can start extending us into. Well, before we get into anything else, though, we do need to talk about average rate of change. Now, average rate of change is basically the idea that if you take some curve, let's for example take a line, and if you didn't remember or didn't know, a line is a straight curve. We usually distinguish between a curve and a line as if they're opposites, but it's more akin to being like a rectangle and a square, where a square is just a rectangle with all equal sides. A line is a linear or straight curve. But for the most part in the future, I and others will typically say a line or a curve. But so let's take a line, a curve like this, and consider 2 points on it. Well, the average rate of change is looking at the overall rate of change, looking at the vertical motion compared to the horizontal motion, what you might call the rise and run. And if you're thinking, wait a second, that sounds a lot like slope, well, you're right, it is slope. In fact, we could even extend this and say, oh, well, it's the x1, y1, x2, y2 setup. I've done it in function notation here, and that is just still the same thing. It's still just slope. So why are we calling it average rate of change, and why does it sound like we're going to be distinguishing between the two? Well, lines are really specific situations that turn out really nice for us. Curves in general are a bit more complicated. So consider not this blue line, but instead let's consider this red curve here. You'll notice that it's still using the same 2 points from a moment ago, and rise and run are still labeled. In fact, I could look at the average rate of change of this curve to get from the blue point to the other blue point. And that is an overall behavior from point to point. It doesn't necessarily tell you anything about individual characteristics of specific spots on the curve, but it does tell you that, well, overall you went up this much, and over this much, yeah, you went up way more than that, and then you ended up coming down, but that's not really what we're talking about. I suppose you could summarize it and say it's literally talking about how you get from the first point to the second point as if you were following this blue line. Well, what then is slope? So slope is better, you can better imagine it as the steepness of a curve. And the challenge with that is that with a line, steepness is the same everywhere. The first segment and the second segment of a line have the same slope because all the points are, well, in a line. Pick any 2 points and it'll have the same slope as any other 2 points. But with a curve, you can pretty easily see that I can pick other point pairs and it'll create different slopes. In fact, you can even talk about the steepness of the curve itself and say, well, yeah, there's one spot on this image here where it sort of has the same steepness as this blue line, like if I were to move it up some, but does that mean that slope and rise over run are really the same thing anymore? To give you a little bit of a visual help with this, again, we could move that point up, but there's a whole bunch of other steepnesses, some horizontal, some negative, some really positive steep tangent lines, things that just kind of don't really feel like this concept of steepness matches with slope anymore. And it turns out we do distinguish between them now. In fact, slope is again what we're going to refer to basically as the steepness of a curve. And because most curves have kind of a changing amount of steepness, this is something that we tend to measure at a singular point. Trying to do it at 2 points, well, you're looking at an average rate of change now. Average rate of change, on the other hand, is the traditional rise over run that we've known about, and it's that vertical versus horizontal movement comparison. And in a line, these are actually the same thing. But with most other curves, they're considered very differently. So when we say slope, we're talking about steepness. Average rate of change is rise over run. And as we move forward, this brings up our first question of how do we find the slope of a curve at a single point? And that's what we'll be answering as we move forward. Thank you very much, and have a good one.